So more graphic. What is the slope-intercept form of linear equation? Anybody? Just say it. What is it? Y equals mx plus b. What does the m represent? Slope, which is also known as what in a real world problem? What? Rate of change. What does the b represent? In a real world problem?
Starting point.
That's the initial value or starting point, right? Okay. So if you have a graph, it's a collection of points, right? And those points are made up of what commas and what's? Parentheses, number x comma y, right? And every point that makes up that graph, that picture, those x's and y's, are they not a solution to the equation that made it? Any one of those x, y's that comes from the graph, if you put it in the equation, would it make it true? All right, that's the whole point. So the graph is just a visual representation of the numbers, right? So this should go fairly quick because we've done quite a few million of these. We have a linear equation, y equals 4x plus 2, and they're asking, does the point 210 lie on the graph of this? How would you find out? Plug it in. So, what am I going to write here?
10 equals 4 plus 2.
Plus 2, right? That's 8 plus 2. Does 10 equal 10?
Yeah.
So that point is a solution to that equation. What about part B? Why don't you guys plug in on your own right now the 4 comma negative 1 and tell me if it is a solution to that equation. Everyone's doing that on their own. Is negative 1, 4 a solution?
No.
No? What did you get in your final line?
4 equals negative 2.
Put it in like that. So 4 equals negative 4 plus 2. 4 does not equal negative 2, right? So no. Okay. Exercise 2, we have a different equation. Y equals 2x squared minus x plus 5. Everybody remember what we call that type of function? Is it linear? Is it linear?
No idea.
It is not. What do we call it? Starts with a Q. Nobody remembers? All right, quadratic, right? Quadratic function. In the graph of it, all the xy solutions form a what shape? Parabola, right? Which will either look like this or like this maybe. Yeah? Okay. So they want to know if point 320 lies on the graph. Okay? In other words, that's another way of saying, does it make the equation true? If it lies on the graph, it makes it true. So let's plug it in here. So the y gets replaced with a what? 20 needs to equal 2 times 3 squared minus what? 3 plus 20. Now, of course, we do what? Oh, 5. Of course, we do the 2 times 3 here first, right, everybody? Oh, man. Oh, what do we do first?
3 squared.
The 3 squared, which naturally is 6, yeah? Okay, thank you. So 20 equals 2 times 9 minus 3 plus 5, right? 20 equals 18 minus 3 plus 5. What is 18 minus 3 plus 5? It's 20. So that point makes that equation true, and it would also lie on the graph that that equation makes. Yeah? Okay, down here it's a little bit different. What do we have down here? What's different down here in exercise 3?
It has a greater than or less than.
These are inequalities, right? Okay. So let's try the first one here. 4 comma 1, plug it in there. 1 greater than 2 times 4 minus 5, right? Well, I shouldn't have put that there. That will go. That is 1 greater than 8 minus 5 is 1 greater than 3. It is not. I'm put a little line through my greater than, right? So no. Yeah. Let's try B. It should be pretty simple, right? What goes in for the x?
2.
Plus 8 less than or equal to 10. Is 10 less than or equal to 10?
Yeah.
It is, so it's a solution. Now, hey, what if it was just x plus y less than 10? Would this be a solution?
No.
No, right? This 10 is not less than 10. Need that equal to sign there. Let's try C. Plug them in. 2 less than negative 3 squared minus 4.
What's like next number squared?
I always forgot that.
Oh,
9.
Positive 9, right, everybody?
9.
9 minus 4. 5.
Is 2 less than 5.
Yeah.
So that is a solution, right? If it was y equals that, would this be a solution?
No.
No, so, right, the inequalities are different. All right, last one here. We'll have y, well, not y, we're going to use a number. Negative 1, is that greater than or equal to negative 6 plus 12 over 3? What's that on top? Negative 6. Is negative 1 greater than or equal to what? Negative 2. You guys still don't understand that positive and negative are different numbers, right? And it's weird.
12. 6.
No, negative 6 plus 12 is 6. That is true. Let's get that out of there. So what do we have here?
2.
Okay. So is negative 1 greater than or equal to 2?
No.
It is not. So it's not a solution. All right? So that's with one equation or one inequality. You also at some point looked at systems of equations, right? What's a system of equations there, kids? Remember? Well, you can take a look.
A collection of four equations joined by the and true condition.
It's all connected with and, right? So in other words, for a system of equations to be true, you need to find some x comma y that makes one of them true,
Both.
both of them true at the same time, the and part, right? So our x, y's need to make them both true. So here's a system of equations, right? They want to know if 3, 1 is a solution to the system. So what do we have to do? Plug them in. So let's plug it into this first one. So does 1 equal 2 times 3 minus 5? I don't know. Does 1 equal 6 minus 5? Does 1 equal 1?
Yeah.
So is that a solution to the system?
No.
We don't know yet. So we got to do what?
Yeah.
Plug it into the other one. So does 1 equal negative 4 times 3 plus 13? Negative 12 plus 13. 1 equals 1 again. So is that a solution to the system, 3 comma 1?
Yeah.
So if that's a solution to these two equations, where on the graph will you find the coordinate 3, 1? If you graphed both of those equations, where would 3, 1 be found?
A 3 over 1 or over.
Yeah, of course it's a 3 over 1. What was that, Hannah? Okay, what do you mean?
Above that.
You've got two graphs with coordinate plane. If 3, 1 is their solution, where is it found?
no idea.
Of course it's got 3-1 because it's 3-1. You know this, we've done this. Where the graphs of the two equations do what? They intersect, yes.
That makes no sense, you're like. I can't even remember.
Okay. That will be where the graphs intersect. It'll be that point at 3, 1. All right. Now we have a system of what down here? Not a system of equations, but a system of inequalities, right? It's going to work the same way, but then, you know, things can be greater than or less than, yeah? So let's see if 5, 15 is a solution to this system. Let's plug it in. So we'll do the first one. Is 15 greater than or equal to 4 times 5 minus 7? Let's 20, right? Minus 7 is what? Okay, so works in the first one, yeah? Let's put it in the second one and see. So it's 15 less than 5 squared minus 10. What's 5 squared, everybody? What's 25 minus 10? Okay, is this a solution to the system?
No,
15 is not less than 15. So it is, right? So this is not the case. So no. All right? If there was a less than or equal to sign, we'd be fine, right? Okay? All right, last little section here. I'm going to let you guys check this on your own, okay? See if negative 2, 5 is the solution to this system. Plug it in and check them both. Bless you. So is this the solution to the system, kids? Or, yeah? Does anyone disagree?
no.
How do you know?
We could have a test just from this. I would like 4.10, and that'd be like the easiest.
Okay? So it makes both of them true. So some of you probably up at the top here maybe just wrote 4 minus 2.
I think plus 2.
It is 4 plus 2, right? Because it's 4 minus negative 2. Okay? All right, we okay on this?
Yeah.
Okay. So we had some inequalities there.